Welcome to Cyber Sentries from Cyberproof on True Story FM. I'm your host, John Richards. Here, we explore the transformative potential of AI for cloud security. This episode is brought to you by Cyberproof, a leading managed security services provider. Learn more at cyberproof.com. On this episode, I'm joined by Mark Fussell, founder and CEO of Diagrid, and co-creator of the Distributed Application Runtime, also known by the acronym DAPR. We dig into how modern distributed applications are transforming how we build and run software at scale, why resilience and security are non-negotiable in distributed architectures, and how agentic AI is rapidly becoming a core pattern in these systems. Mark also shares a look at the next wave of innovations shaping the distributed landscape. Hello there, everyone. Welcome to this episode of Cyber Sentries. Today, we are joined by Mark Fussell. Thank you so much for joining, Mark.
It's fantastic to be here, John. I'm excited to be on the show.
Mark here is the founder and CEO of Diagrid. He really was one of the co-creators of this idea of a distributed application runtime, or DAPR. Mark, tell us a little bit about how you got into that spot. You started creating this, founding this idea, and then creating a company around it.
Well, I've been working in distributed applications for many years, in fact, decades really around these things. My journey through this was probably when I first started, and I worked at Microsoft for many years. In fact, I worked at Microsoft for 20 plus years and got very early into Azure. And at Azure, we had to build a platform to run and build all the major services inside there, particularly database services. So there you are, you're running SQL Server databases at scale. What's the platform look like? So we started building a platform inside Microsoft called Azure Service Fabric. And it allowed you to run these large-scale distributed systems at scale, but it went all the way up to the application developers layer, where you had to sort of build and run and host applications, basically running it and how you could just deploy across a set of VMs at the time. They became containers, and at that time, of course, there are many platforms to build and run these services on. I mean, we had now, of course, Kubernetes is one of those, but we did have things like Mesosphere and Docker Swarm around all these things. And so DAPR was born out of the fact of seeing just many, many different teams build on top of these distributed systems platforms and the struggles that they had. And so what we realized was, hey, what would be really nice is if there was, we could look at these distributed systems patterns, common ways where you do asynchronous communication, how you discover other services, how you do statefulness, and how can we take those and sort of codify them in a consistent way such that any developer can take them and rapidly build their applications, with a distributed or microservices architecture without reinventing the wheel or reinventing the pattern, as we like to say all the time. And so from that, seeing these common patterns, these ways for developers to build, particularly on top of Kubernetes now, the DAPR project, or Distributed Application Runtime project, emerged, where effectively it is a set of APIs for developers to build and run distributed applications. That project we started in 2018. It shipped and became an open source project in 2019. It's been out there for 6 years now. It's quite a while. It got donated to the CNCF in 2021 and has grown to now be a huge project inside CNCF. We have thousands of contributors to the project. There are thousands of companies that use DAPR, the open source project, and it's become a graduated project inside the Cloud Native Computing Foundation, which is sort of the highest pedigree you can get to. And it's utilized, in other words, to build distributed applications. And we could dive into the details a bit more, but that's kind of the broad history of the project.
Well, and one, thank you for contributing to CNCF. We're big fans here at the show of the CNCF, been to many of their events, and just love the way they help the community and the way folks like yourself have contributed to that. So always, my heart's with open source. I'm always happy to see that kind of mature and progress. So that's amazing. Also, really, tapping into what has just become so dominant, this idea of microservices and how powerful that's allowed folks to scale. So what have you seen as that journey over the 6 years that this has been out? How have you seen that mature, and what's that look like now?
what you saw probably if we went back 10 years ago is that everyone was effectively sort of building and putting together their own runtime and frameworks. And in fact, the biggest problem is that someone said, here's this platform like Kubernetes, go and build your application. And before you even got started, you had to think about, okay, I'm building a ticketing servicing app, where I have to order a ticket from one thing, call onto a payment service, and then say, maybe send an email afterwards. And the first thing you have to do is sort of discoverability between these things. So we just saw all these teams having to sort of build a communication system, effectively maybe built around a message broker like Kafka for pub sub messaging, or one of the ones from one of the clouds like Azure Service Bus or Google Pub Sub or AWS SNS, and then sort of having to stitch together and sort of send messages between these systems. And then, of course, you had to kind of have to do security between them. And I think one of the greatest innovations that we did inside DAPR, particularly focused on security side, is what we focused on is application identity. And this is really, really key, because what happens today is that you really want to be able to say from a developer perspective, I've got service A and I've got service B. And rather than me messing around with ports and networks and IP addresses and all that sort of horrible, messy stuff at the bottom there, as a developer, you just want to say, hey, I've got service A. I just want to discover and call this method on service B or send a message to service B. What's the identity of that service? And so DAPR installs this key principle that when you fire up a piece of code and it's just a piece of process that's running, it gives it a piece of identity. And that's actually allocated by a SPIFFE identity. So SPIFFE which is another CNCF open source project, is the identity is given to one of these processes of code. And now you can do some clever things between it all. You can do calls between services and discoverability. You can actually sort of limit calls between two different services. Service A can't call service B. We can do things like this particular piece of code can only receive these messages. So that security principle got bedded deep into DAPR. And then around this, of course, you started to build sort of other services and APIs that DAPR has. So going back to your question about the journey, DAPR itself started with a lot of communication, and they started with then statefulness, you could start state. And then most recently, in the last 2 years, we developed a workflow engine into DAPR, which allows you to do effectively, when you have a microservices application, you often want to do coordination across these services. Call service A, call service B, and then do something to C, or do these two in parallel. And particularly, this is often referred to as durable execution. If everything fails, you don't want to have to go back, restart from the beginning again about where I was in my business process. I already reserved my ticket and I'd done my payments and I was about to send my email when everything crashed. And so I didn't know I bought this ticket and actually it was successful. But rather than start all over again, the workflow engine kind of just picks up where it left off and continues going. And I think this is probably one of the most crucial aspects and the hardest part of building these applications, because it's great to kind of build these individual things, but the coordination, the durable execution, the recoverability, the resiliency, and sort of making sure that you don't have to go back and figure what you ran before. And if things do go wrong, deal with compensation is pretty important. So that workflow engine part of it, combined with the communication of pub sub messaging and all of these things and deep security, I think became a dominant factor inside DAPR today. And it's what we see as kind of the greatest use case: workflow combined with messaging, like pub sub messaging.
Yeah, I'm not surprised, as somebody's had to try and debug some of that before. If you don't have that kind of durability, that it can be a nightmare when you've got problems and then you don't know where you need to, your operation failed and now you don't know which step you're in. So
exactly, yes. And the good thing about DAPR, what it also does is it also has this great security principle where it actually provides a set of APIs, but you could swap out the underlying infrastructure behind those APIs. So it allows for this great adaptability and sort of evolution of your code, and also just change of design choices. So let me give you an example here. It's quite common for someone to start with one particular message broker. Say they start with, and this happened to a good example of this is with FICO, for example. FICO, they did a talk at KubeCon last year, if you attend that, and they talked about how they started off with Kafka as a message broker, but in time, they ran into some scale and some performance issues and wanted to move instead to Apache Pulsar. Well, what DAPR provides is that you can have this concept of a component model which merely describes the sort of this metadata of how you can talk to the underlying infrastructure. And the component brings in all the best practices for a particular piece of infrastructure, like a message broker. And so you could call onto the pub and subscribe API, but underneath you can swap out Kafka with RabbitMQ or MQTT or any one of the other cloud message brokers without having to change any of your code. And this makes it amazing because particularly for sort of platform engineering teams who want to control over who has access to what particular piece of infrastructure, but not having to tell all the developers, hey, we've just have to tell you to throw away all your code now that you've bound to this particular API, SDK like Kafka, and now rewrite all to go against this other SDK, which may take months. You sort of just keep the same API, but swap the underlying infrastructure. So this provides, sort of a great contract between the platform engineering team and the application developers. It also provides really good security boundaries around this as well.
Wow. So I can immediately see the value of that brings, but it does ping in my head. Everybody's talking about AI right now and using new models. How does this apply to that? Is there a world where you are swapping, are you thinking about how Agentic fits into this? Can people swap though? I've got too many questions right now. So.
Well, you've asked the right question, because what we introduced earlier, actually at the end of last year, this year, was an API into DAPR called the Conversation API. And the Conversation API is an API that allows you to plug behind it any language model of your choice. So you can plug in Anthropic or OpenAI or DeepSeek or any one of these application models, and then it's just got an API that's just a prompt API that you call onto. But your underlying model can just be swapped out without having to change the API. So that's just a very simple way of kind of having this swappability and this sort of, we can do this evolution of try out a lot of these models, switch. And they're switching out all these components. And so the community is now going crazy because they're plugging in all of these different models into DAPR that you can use, keeping the same API. And DAPR does provide intelligent things on top of the API, because it does also add capabilities. Actually, two things it adds on top of that is obfuscation of data. So if you have any privacy data coming back, and it also does prompt caching. So it kind of saves you some money if you reuse the same prompt, and it sort of adds those features. So that's one of the ways that gets plugged in. But what we've also seen really is this rise of agentic AI systems. And the way I look at agentic AI is that you have these classic microservices architectures that you've used that typically write very deterministic code. This sends a message to that and sort of workflow central to this. But now, all of a sudden, you're wanting to plug in language models, through this Conversation API that we included in DAPR. And so using that plugged in with, the agentic AI direction, is we actually developed and put into DAPR a concept called DAPR agents, which basically takes advantage of all these DAPR building blocks, the ability of messaging, the ability of workflow, the ability of the Conversation API, and stitches them all together. So you can create first-class, really durable, enterprise-ready agentic applications.
Well, that was what I was going to ask, because as you talked about workflows, there are challenges with making sure everything's consistent with some of these sometimes, and being able to apply those to an agentic setup would be huge. So it sounds like you are able to pull that inside when you're using this kind of DAPR agentic model.
Exactly. So, the way I look at agents is that, they are distributed applications with smarts, adapting language models around more. But the biggest thing about these things is that they do a series of steps. They go and call this language model. They then access, maybe some database to get some data from it, or they then maybe query another system. And you don't want it to halfway through, it was just about to ask this language model, and it was a very complex prompt query, and then it dies, and then you go, well, okay, I have to start thing again, and I just spent a bunch of money on this. So core to DAPR agents is workflow embedded inside door to give you effectively what we call a durable agent. And a durable agent means that it's gone through all the steps, but is fully recoverable in its state. And I think this is the biggest challenge with a lot of agentic frameworks today, is that they don't handle the durability at all very well, and they kind of, it's okay if you have very simple agentic systems, but you need strong durability in order to make sure that you have this recoverability. You need strong messaging around these things. And so one thing I'd encourage all your listeners to do is we'd love you to go and try out DAPR agents. It's a very simple model. You can either build a single agent that just sort of runs by itself, or you can run this concept of a durable agent that uses workflow and reasoning around it all. And there's a lot of cool examples of that.
Now, on the security side, how do you make sure, does this identity component you were talking about earlier, is this layered on top of here? How do you make sure your model has access to only the right data or is talking to the right services as it goes through?
Exactly. So because DAPR is built on the security principle of identity, the actual workflow and therefore the agent itself has identity associated with it. And so that makes it very secure. And then when it spawns or it runs out its separate own workflows, they too have identity associated with them. So you can very much say, I can keep this security boundary around what my agent is talking or distributed and running in my system, as well as also, when you going back to that component model, in that component model, if you use the DAPR components, you could say only this agent is allowed to talk to this piece of infrastructure. And so you can sort of time bound it around there. Of course, the greatest challenge with agentic systems as a whole is that they don't run in isolation. And so you get into this world of agentic systems and how they talk to other services. I'm sure you've talked a lot about MCP and the MCP protocol and what that's like. There's a lot of challenges with that today about how you can have security in that, and how there's a lot of sort of threats and sort of tool. And what was it? There's the tool of threats where people inject, they can do prompt injection attacks and they can do tool injection attacks on all of the MCP protocol. So although DAPR supports all of that, the actual ecosystem as a whole has got a lot to work on about the security with MCP and A2A around this. And I think that will get there. But certainly when you build with inside DAPR agents themselves, the identity side of these things provides a lot of sort of security boundaries for you.
Yeah, that's huge. Now, as you're working on this, where do you see things going next? Because, things are escalating so quickly with the advancement of AI. So what areas is DAPR and then I guess even Diagrid, where is effort being focused as you see AI becoming larger and larger?
Yeah, so I see that, what's going to happen is that you have to expand this world where the classic, microservices architectures was driven by a business need. And the business wanted to accelerate their development in order to be able to ship things fast. And they are, the best way today of building applications that are resilient and durable and sort of mission critical. And typically Kubernetes is a platform that runs on top of that. But what's happening is that you get a lot of language models, or let's just say models in general, because it could be vision models and other sort of predictive maintenance models and in many applications that are going to take advantage of AI in order to do things. So you're already seeing this emerge in some classic cases where sort of like medical industry, where they can build an agent that looks through thousands and thousands of cases of medical imaging records in order to detect sort of medical cancer growth or anything else like this. And so the concept of an agent working on behalf of a human doing some things, but typically needing human in the loop to do this is going to be critical. So you've got to span this world of microservices development with agentic systems emerging inside all that, where the models are sort of doing a lot of work on behalf of humans, but needing human in the loop. And of course, having that communication between them all. But at the same time, you want it based upon sound principles. So that's where we see DAPR come in. We want to take DAPR, not only build DAPR agents and try that out, but we're taking DAPR and applying it to any agentic framework, whether that's LangChain, Crew AI, semantic kernel, and saying, hey, we can bring these like durable workflow execution, this great communication to these other frameworks as well. So we see that happening. We want to be able to kind of blend DAPR into this agentic system as a whole. We believe that its security principles, its communication is kind of very strong as part of that. So that's one thing. And then, generally, what we also see is that, the language models themselves are getting more and more intelligent. And so this whole concept of reasoning and, how does a model think about things and go in depth and sort of decide what it's going to do. I think it's a bit fascinating world one day where we have these sort of robotic little assistants working for us. Today it's great having sort of a little virtual assistant. Maybe it's looking through my CRM database, finding cases for me to send, and maybe it's looking over medical records to do things. I'm sure you're really talking about sort of airlines are only talking about having every person that comes to them has their own little personal assistant that helps them rebook their flights. And so rather than you having to figure this all out, and certainly that will emerge. Of course, I think the truth around this all becomes is how enterprise capable are they? And being built on things like workflows and having workflow durability and security is key to all this.
You mentioned, different types of agentic here. I tend to, because they were the ones that grew fast first, LLMs, but you've got this vision and other pieces. Is it very different as you look to bring in those kinds of models? Are there new things you're considering, like size of data? Or at the end of the day, is it, hey, you just treat it as another AI agent and it kind of fits in a bucket regardless of what type it is?
Yeah, I just think that, we just got to recognize that other types of models are good at doing things. I mean, I think vision is the main one, is that it's kind of been dramatically shown that vision models are great at recognizing images. And so you get these systems that are built, for example, that just do vision, in part of automation. I remember working with an auto car company, and as the car goes through in its manufacturing, they literally have 100 cameras around this car looking for all sort of defects on their door, rather than a person inspecting the door. Like, for example, they get fanatical about does the door close and is the width of the door exactly right, and it has to be like within a tenth of a millimeter accuracy around these things. And so there's a vision model that just looks at that and is checking the quality control of the car and doing all these things. But it's still in a process automation scenario where you have to go through a series of steps around these things. So that's the sort of scenarios that you get in order to sort of combine vision models, and you get other these predictive maintenance models that look at acoustic patterns with inside engines and what's happening there from when they're going to get maintained. They get these large industry engines, and they listen to the acoustics inside them all, and as it starts to get to high pitch whines, they know it needs to shut down for maintenance and things like this. So that's the thing. But in the whole part of the business workflow, you still need to do step A, step B, step C, and still need to build a car. You still need to sort of run the industrial equipment. So that's where they sort of fit in. And then, and the agentic applications are just going to be combining the models. I think language models, although, are the one that's sort of top of the mind because they're very humanistic. Yes. And that's where, you engage with humans and ask it, book me a flight, or, what's the latest, most likely people I can send a targeted email list in my CRM system. So they're very simple today, but they're going to get more and more complex, especially when we fall into these multi-agent systems. And so I think that the whole security world is going to explode and get ahead in kind of a little bit blown away when we start talking about these multi-agents talking to each other. Because, I mean, who do you trust? Like, how do I know who's sending to what? I mean, I have no idea how I'd ever do this one. But somehow we'll have to have like a trusted agent somewhere that I trust. And if we get into these agents talking to agents, which everyone is very excited about, I think trust relationships will be enormous.
Yeah, it's a whole nother and it's like, it still goes back to some of the fundamentals, but the stakes just keep getting higher and higher as less and less concretely about what it knows and what in those cases.
Yeah. So we're going to have these approved agent registries. These are the ones. I'm sure there'll be sort of control at some point, but how you then have to trust the authority that controls the agencies around those things and things like that. And I'm sure that some of the major cloud providers will sort of build these general purpose agent registries in time. That will happen. But I mean, I think the important thing here is that it's going to take a long, long time to get there. And, the concept of distributed applications is still at the heart of this. And so that's where, DAPR itself fits in well. And that's where we at Diagrid are working pretty strongly, because we've built a product called Catalyst. And Catalyst allows you to build and run distributed applications based upon DAPR and using its APIs along with agentic applications, and sort of provides you with a platform for running workflows and these agentic applications that's enterprise ready. And so we very much think of enterprise ready quality agentic applications running in very sort of mission critical scenarios.
So this would be for folks that have maybe a distributed system set up already, but they're like, I want to start adding in agentic to this. And if I'm understanding right, you correct me if not. And then like Catalyst is basically a way to say, hey, here's how you start to maybe marry those things together. Run your distributed, but also start bringing in Agentic easily and, enterprise safe and secure and scalable.
Exactly. Yeah. So, what we recognize is that, there we have is DAPR. DAPR is a set of APIs that allow developers to be amazingly productive about building distributed applications with pub-sub messaging, workflow, service discovery and communication, state management, and secrets. We've combined those together to build DAPR as an agentic framework. And so Catalyst is basically, think of it as a DAPR server. We deploy this into a customer's infrastructure. It has the concept of projects. It has, for example, a visualization for your workflow, visualization for your agents. It has the ability to kind of do auditing and RBAC control. And you can now build your application on any compute platform that you choose. You can run your applications on VMs. You can run your applications on container platforms. You can run it on, say, like functions. But you could take advantage of the DAPR API, such as workflow and, for example, agentic systems and communication in order to build your distributed app. So common examples are, we're working with several large sort of financial companies who are deploying DAPR into their environment, and they're using it as a workflow engine because they've got to create payment services or they've got to create other sort of business workflows around these things. So think of it as a code-first workflow engine, which is very developer-friendly. And because it's a code-first workflow engine, it's very easy to debug code, and it's very easy to and it's multi-language as well. So you can write part of your application in Python, part of it in Java, and sort of marry it all together. So DAPR is very multi-language friendly. The workflow engine's code-first based, which means that developers can easily debug it with your environment. You don't have to worry about domain-specific languages and all of this side of things that some of the older style, I would say, BPM engines had. This is a code-first. I write a workflow type and then have a series of activities inside this all. And then I can point this to any database of my choice, like a PostgreSQL database, to store all the state and recoverability. So think of Catalyst as a server that runs workflow at scale with a lot of enterprise capabilities, visualization, and allows you to do code-first workflow and build very kind of resilient enterprise-ready applications. Does that make sense?
It does. It does. Well, thank you so much for coming on here. This has been so fascinating to hear. Tell folks where they can learn more about Catalyst, how they can find out about it, and of course about Diagrid as well, and the CNCF project.
Yeah, so if you want to find out more about DAPR, go to DAPR.io is the project space for that. I would encourage anyone who wants to get into DAPR to come and join the DAPR Discord server. We'll post a link to that afterwards. It's a huge community. There you can find out and ask questions about building Microsoft's architectures or DAPR agents. And then my company, Diagrid.io, and at Diagrid, we effectively provide support not only for DAPR open source projects, if you are starting to use DAPR in any of your deployments, but we also provide Catalyst as this workflow server that you can deploy and run in your environment. So you can reach out, or you can reach out to me directly. I'll post my email at the end of all this. And I'm happy for people to send email directly, Mark at Diagrid.io, and have a conversation with them. I'm always open to talking about DAPR, distributed applications, agentic systems. Love to hear more about it all. It's a very, very exciting time. And it's an amazing time to be a developer as we sort of go into this sort of autonomous world of development. And as you see, not only in code development, but actually in sort of systems development.
Well, thank you so much, Mark, for first coming on here on the podcast. It's been super informative. Also, for all your contribution to the CNCF. Appreciate that. Everyone, go check it out. Check out the Discord. Check out Diagrid and Catalyst as well. And thank you again for being a guest on here. So glad we had you.
Thank you for having me. It's been great.
This podcast is made possible by Cyberproof, a leading managed security services provider helping organizations manage cyber risk through advanced threat intelligence, exposure management, and cloud security. From proactive threat hunting to managed detection and response, Cyberproof helps enterprises reduce risk, improve resilience, and stay ahead of emerging threats. Learn more at cyberproof.com. Thank you for tuning in to Cyber Sentries. I'm your host, John Richards. This has been a production of True Story FM. Audio engineering by Andy Nelson. Music by Amit Sagi. You can find all the links in the show notes. We appreciate you downloading and listening to this show. Please take a moment and leave a like and review. It really helps us to get that word out. We'll be back October 8th right here on Cyber Sentries.